So it's Jason here at the Retro Computer Festival 2017 here at the Centre for Computing History. I'm here with Dave, who has brought in an amazing collection of kind of modern retro. I think it's probably the best description for it, isn't it?
Yeah. Reproduction.
And what we're looking at here is an Apple I, an amazingly beautiful piece of equipment, fantastically built, really impressive stuff. So, Dave, tell us about it.
Yeah, like you said, it's a reproduction Apple I. Board's been designed by a guy in America, Mike Willigal, and he's basically reproduced the board with all the traces pretty much spot on to how the original was. So he's used high resolution photographs, and I believe he's had the board x-rayed, one of the original ones,
right,
just to get the detail spot on it.
Fantastic.
So, yeah.
So more than just build this to look good, I mean, this baby actually works.
Yeah, absolutely.
Fantastic.
Yeah.
Right. So can you tell us a little bit about it? So the board itself, we've got a linear power supply at the top there.
Yeah.
Top right corner.
You've got the power coming in to the transformers here. You've got power switch in a little black box there. And then it's basically feeding up to your main 5-volt regulator there, which is very hot. And I just
runs hot, does it?
Yeah. Oh, it runs about 80 degrees C.
Ouch.
So it's it's a bit toasty. And then you've got your plus 12 volts, minus 12 volts, and also minus 5 volts.
Okay, so what did it need plus and minus 12 as well? I mean, it's just basically a TTL logic board.
Yeah, basically your RAMs, I think they also use, along with the plus 5, it's plus 12,
okay,
and it's some of the shift registers for the video display as well.
They need 12 as well?
Yeah.
Okay,
yeah.
Interesting. Sorry, yeah, carry on. So bottom half of the board, that is...
Yeah, basically that's your computer section down there.
Right.
So you've got lower 4K of memory, upper 4K of memory. So some original boards only shipped with the base 4K. You've got your memory decoder and address decoder in there. You've got your 6502 CPU, keyboard interface, and then the two chips down there are the monitor ROMs. So 256 bytes of onboard ROM.
Right.
And then basically there's an 8-bit bus which goes up to your video section.
Right.
And up there again you've got your character generator ROM, and you don't have video RAM as such, or you do, but it's basically shift registers.
Right, okay.
So your data's coming in, these are each 1000 bits serial shift registers, which at the time it would have been cheap to produce, I would imagine. But it does mean that your screen acts like a terminal. So you can't clear the screen through software, and you can't delete, you can't move the cursor position. It's purely the data goes in and then is made out.
Really rudimentary.
Yeah. It's
But then
simplest form.
machine was designed to be a cheap kind of home computer,
absolutely.
so you've got to take every cut you can.
Yeah.
And I suppose video chips at that time would have been relatively expensive, so out of the question.
And obviously he just wanted to build a computer.
Yeah.
And the Apple II was evolved from that, but was a huge improvement.
I mean, he designed this as a video terminal in the first place, I think, wasn't it?
I believe so.
Yeah, I think so.
Yeah. There was some discussion of whether some of the work was copied from Don Lancaster's TV typewriter, but it turned out it is pretty unique the way he's done it. So, yeah.
Wow. And then you've got a keyboard down the bottom that looks absolutely spankily new.
That's because it is.
Right.
Yeah. eBay deal. It was new old stock from an Apple II clone, ITT 2020.
Right.
So yeah, it is nice and shiny new.
Beautiful. So this was just straight on it. Are they still on eBay?
No.
Oh,
no.
what?
No.
We need one for
I kind
ours.
of bought a few of them, so...
You bought the last of the stock?
It was a job lot, so it'd be rude not to.
Yeah, well, it was rude doing it, actually, I would like to say, but anyway, whatever.
Move on.
Yeah. Okay, so that's cool. So that's an Apple II clone kind of board then, right?
So you just got your ASCII encoded output there. There's a little board in there which just converts a few of the pins and just maps it correctly for the Apple
That's
One.
really nicely done, really nicely done. So your little box there with your power switch and then composite video out, is it?
Yeah, so it's just taking the composite video from the top of the board, just running it down there to a phono socket there. Just makes it a little bit neater.
Right.
Yeah,
there she works. So you see her in action?
Proper chunky power switch. So you power it up, you just get a screen full of garbage
so
usually.
it's not initialised, so it's just kind of junk, right?
So you've got a basically press one button which clears the screen, and that's the only way, say, of clearing the screen. And then reset the processor, and now you're running the code from the monitor ROM there.
Okay, so it's got an onboard monitor ROM.
It does, yeah.
But that's it. There's nothing else on there.
That's purely it on the main board itself. On the cassette interface down there, you do have another 256 bytes of ROM, and that's purely for the cassette I/O.
Right.
So,
okay.
Other than that, all you can do on the monitor ROMs is dump memory, edit memory.
Right.
That's pretty much it.
Cool. Okay.
Yep.
So, can we load something into it?
We certainly can. So you got to basically, first of all, switch control over to the software on the cassette interface. So call that up, which is in hex, is that memory address. R to run. So now you're running the code from the cassette interface.
Okay.
And what you've got to do next, to load the program in, you've got to specify which area of memory that code is going into. From memory now, demo software, it's 280 to... So again, you're giving it a memory address, and R is to read into memory. If you wanted to dump that section of memory to take, it's W. So it's just the opposite way around. So then turn, press play, and then it should load into memory.
So it's now loading. It says nothing to show you what it's up to.
No, the only feedback you can get is the small LED on the cassette board. But it's a bit temperamental on how reliable that is. If it doesn't load, it's usually a case of adjust the volume and then try again. Right,
standard 80s, mess with the volume.
Pretty much, yeah.
Okay, cool. So how much code is there? How long is this going to take to load?
It's just under 4K size, probably closer to 3K. And you'll know as soon as you get the cursor prompt back, the backslash prompt.
So the prompt is the slash, it'll return to the slash and then... Right.
Which I don't believe is actually accurate. I think I've got the wrong character generator.
Oh, right, okay.
But we'll ignore
for
that.
us today, it's a slash.
Enough.
Right, yep.
Yeah. So that you can
that's
tell
loaded.
That's loaded.
Right.
So all you do is specify the address you want to start the code.
And then R to run
again.
Right.
And there we go.
Okay, that absolutely magic.
Yeah.
Yeah, you can see what's coming up. Yeah.
Yeah. If you stand far enough back, it almost looks like graphics.
Looks like, it does.
Yeah.
It really does.
Yeah.
The legend himself.
There he is.
Woz, this is for you.
Yeah. Thanks, Woz.
Magic, yeah, absolutely. Yeah. Well, I mean, without this machine, no Apple II.
Exactly.
No Macs, no, well, who knows. Yeah. But that's fantastic. That is a really cool build. It's beautifully done in that case there as well. And yeah, thanks for bringing it along today. Really appreciate it.
More than welcome. Thank
you. Yeah, and then maybe you can help us get ours populated as well if you find any old components.
Absolutely. Yeah. Do you want to buy a keyboard?
Yeah. But we'll do a deal. We'll do a deal off camera though.
Yeah. Cheers.
Nice. All right. Thanks a lot. Cheers, Dave.
Cheers.
Thanks a lot.